Hello, welcome to the presentation of my bachelor's thesis. My name is Martin Muzikáš, and this thesis delves into the topics of software verification and user effectivity. The easiest way to test a web application is to use interactive testing. What interactive testing does is it records all your interactions with the web page and stores them. The interactions that are recorded are based on selectors that the program decides. You don't get to decide this, so you are risking that when a selector changes, when something on the web page changes, you will have to redo all your tests, which is quite a taxing thing to do when one small change breaks your tests. Also, testing for some condition on the page, as you can see in the video right now, is done through commands which break you through from the page, and you have to look into the IDE and find it. Also, it records a bunch of nonsense when you are trying to copy it, and when you look at the output, it isn't really maintainable and readable. You don't really know what is tested right now. Behavior-driven testing is a model-based testing approach, which means all your interactions with the web applications are abstracted into what's called steps. In the demonstration, I'm writing a scenario to test a simple web page where the step definitions are already written, but I still have to look at the definitions because the step definitions are defined by regular expressions that you have to match in order to perform the actions, and it's not easy for the users to remember these step definitions. However, it produces easily readable output. It aims to be understandable for all parts of the software production team, not only quality engineers but also any other stakeholder. Thanks to this simple format, it also serves as a live documentation of the application and specifications of the features that the application provides. So there are huge benefits to using behavior-driven testing. However, the user experience isn't the best. So that's what I try to improve. I mean, look at the footage. It is sped up, and even then it lost all of its color because of how painful it was to write. But jokes aside, the job is not done because you still need to test the test scenario to know that it actually tests the application and you wrote everything correctly. This is similar to compiling your program. I won't bother you with the details, but you can see that the test failed on the first try, which happens quite a lot when you are writing a test scenario. And keep in mind, I wrote the step definitions like a few minutes prior, so that speaks a lot about user experience. And my solution to these problems is to combine both approaches, meaning you are still going to be writing behavior-driven testing scenarios and code, but you'll see the scenario you are currently writing playing out right in front of you as you are writing it. Meaning, when you make a mistake, you are going to immediately see what the problem is, and you are going to be able to solve it, or at least inspect the application while it's still running, because in the old approach the application just closes and it reports an error. So to just be able to observe what went wrong during the testing is a huge benefit, and to be able to recover from the mistake is a huge benefit and effectivity booster. Also, as you can see, a huge benefit is that I don't have to look anywhere else into any code while I'm writing the scenarios, because the step definitions are listed just in front of me, either in the step list or in the editor. Also, you can see the test suite output is shown in the application, which means you will immediately know when an error happens, or when you are using logs for debugging information, this information is still going to be displayed and available for you. This is possible using Java instrumentation, which is a mechanism that allows you to modify existing code. So what I'm doing is modifying the existing test suite to allow for this behavior, to allow running steps on demand. The UI is written using React, and the editor you can see is provided by the Monaco library. You may think this editor looks familiar to you, and this is due to a Monaco editor being built from Visual Studio Code. So it provides a lot of functionality and it has a huge user base. However, some functionality differs from Monaco Editor to Visual Studio Code, and the Monaco Editor library isn't the best documented, so part of this thesis was also documenting the functionality and differences. Another benefit of having the application under test running alongside your test is that you are able to provide the data that your steps are willing to accept to the editor, meaning that you are essentially able to provide your own autocomplete values if you implement a simple interface and provide the values you are willing to accept. These values are going to be then displayed in the autocomplete dropdown. In the future, I'd like to work on this more and provide ability to execute custom code from the editor, so you don't have to always restart the test suite. Also making this more portable, meaning right now it is suited to one or two versions of the libraries used in the test suite, and it would be great if testers could just add one dependency or one Maven plugin, and this would work out of the box for them. That is all from me. Thank you for watching this video, and I hope I made you a little bit excited about the future of testing and about the possibilities to improve things further. Thank you.